Okay, so we're starting a new section, 5.2. This is adding and subtracting of polynomials or addition and subtraction of polynomials. So here's some vocabulary terms we need to know. Number one is mononomial. What is a mononomial? It means a number, variable, or product of numbers and variables raised to natural number powers. The degree is the sum of the exponents. The coefficient is the number in the mononomial. Okay, so let's read that again. A mononomial. A number, a variable, or a product of numbers and variables raised to natural number powers. Okay, and here's the other part. The degree is the sum of the exponents, and the coefficient is the number in a mononomial. All right, so here's some examples. So these here, 4x squared y, negative 6x squared, so on and so forth, are all mononomials. They're just single terms. They're a number, variable, or product. Product means you multiply, right? So x squared times 9. Okay? Raised to natural number powers. So remember, natural number starts with 1. Okay? 1, 2, 3, 4, 5, etc. So can't have a negative or anything like that. All right? So, and it tells us that the degree is the sum of the exponents. So in this case, we have a power of 2, x squared, and then y to the power of 1. So 2 plus 1 is 3. That's why this is a degree 3. This next one, negative 6x squared, is just a power of 2. So that's why the degree is 2. This next one is the power of 4. That's why this is a degree of 4. The next one is the power of 1, x to the 1 power. That's why the degree is 1. And this one doesn't have a variable, but technically it's x to the 0 power. Okay? So this one would be x to the 0 power. A lot of times, we never write it, but we can write it as negative 8x to the 0 power. But remember, x to the 0 power just means 1. So this is saying negative 8 times 1, which is negative 8. Okay? So anyway, that's where the degree of 0 is coming from. Okay? And then the coefficient is just a number um, in front of the mononomial, is a number in the mononomial. So in this case, the coefficient here is 4. This one's negative 6, negative 1, number 1, and number negative 8. Okay? All right. Polynomial. Polynomial, it means a mononomial or the sum of two or more mononomials. So here, the bottom one here is a mononomial. It has one term. Okay? This one is a binomial because it has two terms. It has negative 9x to the fourth and then 100. So that's a binomial. Okay? And this one is a trinomial because there's three terms. 1, 2, 3. So that's why it's called a trinomial. Right? So basically, it's a polynomial is the least it can have is a mononomial, and it can go on or more. It doesn't have to be the trinomial. Doesn't mean it's the max it can have more than that. It can have infinity actually. Infinite amount. Okay? So that's what a polynomial is. Okay, and you guys are familiar with this like terms. So mononomials containing the same variable raised to the same powers. So here you have x and x. So they're the same. Okay, so they're like terms. This has ab squared and ab squared. So those are like terms. You have x squared, like terms, and z like terms. Okay, so in order to do anything with them, if you're adding, subtracting, you have to have exactly the same variables that are being raised to the same powers. Okay, so if this was, say, 5a squared b squared, then these two guys here don't match. so you can't do anything with them. But since this is only a to the first, this is a to the first, b to the second, b to the second, then you can do something with them. Okay? But again, if it was a squared, then you couldn't do anything. They wouldn't be like terms. Okay, so this one, it wants us to determine whether the expression is a polynomial. If it is, state how many terms and variables the polynomial contains. Then state its degree. Okay, so let's number these. 1, 2, 3, 4, 5. Okay, so we need to determine yes or no if it's a polynomial. Okay, then we need to state how many terms it has, and then the degree. All right. So for the first one, is that one a polynomial? 7c. Yes or no? Yes, right? That is a polynomial. 7z is a polynomial. Remember, it can be one or more terms. So yes, this is a polynomial. All right. How many terms? Well, there's only one term. Okay. And then the degree here is what? Just one, right? Z to the first power. Okay. How about the second one? Is that one a polynomial? Hmm. It is, right? This is a polynomial, right? So let's go back to here. You can have just a number, right? So erase this part here, right? You can just have a number, all right? But normally that number is x to the 0 power. They don't write it, but that's what's there. So this is a polynomial, okay? And how many terms? Well, there's what? Two terms, 1, 2. Okay, so this is yes. This has two terms, right? And then the degree of this is, well, 3, right? That's the degree. All right, how about number 3? Is that one a polynomial? This one's tricky. Yes or no? Hmm. This one's not a polynomial, right? Okay, because it's being divided. And if I were to rewrite this, it would be like 5 times xy plus 1 raised to the negative 1. Okay, so anyway, it's not it's not a polynomial. Okay, so because again, it's in a fraction form. You have to be careful, sometimes it can be, but in this case, it's not. Okay, just depending on how they write it. This one can't do anything here. So this one's no. Okay, so number 4. All right, how about this one? Is this one a polynomial? Is that a polynomial? Yes, good. That one's a polynomial. Okay. All right. And then how many terms do we have here? Just one term. This is all being multiplied as one term. If it was, say, 5 squared plus a cubed plus b to the fourth, then yes, that would be three separate terms. But they are being multiplied, so that's only one term. So remember, it says here that it can be a product. A monomial is a product of numbers and variables raised to natural number powers. So here is um, it's a polynomial, okay? Because they're being multiplied, and there's only one term. Okay, this one's a kind of a tricky question. What's the degree here? The degree here is going to be 7. All right, so you just add up the powers. Okay, so you would add up the powers. So 2 plus 3 plus 4 will give us 7. That's the degree. Sorry, 3 plus 4 will give us 7. Okay, so it's the adding up the powers with the variables, not with the numbers. Okay, how about number 5? Is that one a polynomial? Yes or no? No, right? This one's not a polynomial because it has raised to negative power. It can only be a natural number, right? 1 through whatever. Can't have a negative in there. Okay, so this one's no. Okay. All right, any questions here? All right, let's go to our next one. All right, so this one says state whether the given pair of expressions are like terms. If they are like terms, add them. Okay, so again, let's label this 1, 2, 3, 4. So that's our question. Are these like terms? Okay, if so, add them. So let's look at number 1. Is number 1, are they like terms? Despite the coefficient. Yes, right? These are like terms. You have x squared and then x squared. They're like terms. This is 1. So they're like terms. Yes, they are like terms. Remember, despite the coefficient can be remember that the coefficient is the number in front of the variable. Okay, that can be any number. Okay, so they are like terms, so I can add them. So 1 plus, so this will be 1x squared plus 8x squared will give us 9x squared. Okay, how about number 2? Are those like terms? Yes, very good, right? And despite the coefficient, the number in front of them, we don't care about those. All we care about is the variables. So in this case, yes, they're the same. You have x times y, you have x times y. So those are like terms, and then we can add them. If they are, we can add them. So 4xy plus plus. Well, it'll be a minus now, right? Because it's plus a negative, so it'll be a minus 9xy. Okay, so that will give us a negative 5xy. Because remember, the minus will trump that that positive. Okay. How about 3? Are those like terms? Are these like terms? Are they the same? No, right? These are not the same. This has an x squared. This has an x. This has a y. That's a y squared. So number 3, are they like terms? No, they're not. So we can't do anything to them. Okay. The last one there is tricky. How about these ones? Are these like terms? So would you agree? Yes, good. Would you agree that 2 times 3 is the same thing as 3 times 2? Right? These are the same. I can multiply 2 times 3 is 6, or I can say 3 times 2 is 6. They're the same thing. So the same thing. I can write it as r times t or t times r. They're exactly the same thing. Okay? So here we have rt squared. So r times t squared. Well, the t squared and the r just flipped here, but I can rewrite this as rt squared. So these will match this one, right? And I can put the -2 in the front. So they're the same thing. Okay? We have a r, we have a r, we have a t square, we have a t square. So they're the same thing. So that means that these are like terms. Yes, they are. And then we can add them. So we have rt squared plus or minus, doesn't matter, t squared r. So that will give us minus 1 t squared r. Or you can say minus 1 rt squared. It doesn't matter. They're saying the same thing. We want to either subtract or add these terms. Okay? So in order for us to add them, we have to have the same like terms, despite of the coefficient. So I would start matching them up. So z4 will go with this one, right? There's no z square here, and there's no 4z over here. But these guys, they are the same like terms. So we'll have 4z4 plus a negative z4, okay? And then the plus z squared plus 4z plus, and this will be negative 10 plus negative 5. Okay? I'm just emphasizing we're adding, so that's why I'm putting those there. All right, so we have 4z to the fourth plus negative z to the fourth. Well, that's just taking away 1 from the fourth, so that will give us 3z to the fourth. Okay? Again, this one we don't do anything, it's just z squared and 4z. But this one we'll have negative 10 plus negative 5, so you spent $10, you spent another $10. That will be down by $15. So this will be a minus 15. Okay, so that's our answer for this one here. Now this one, we have to be careful because now we have a minus here. So that means we have to distribute that minus to each term before we do anything else. So this becomes a minus 4z squared minus 5z minus 1. Okay, so then I can now subtract these guys. So we got z cubed. There's no z cubed, but there is a z squared. So we'll have negative 2z squared minus 4z squared. So those guys are out. Okay. And then we have a minus z and a minus 5z. Okay, second here. Yeah, so here we have so let me simplify this. So I'll have negative 6z squared. Sorry. All right, and then we have the z cube. So z cube minus 6z squared because it's coming from these guys here. Okay, and then got minus z and minus 5z. So minus z minus 5z. So that's going to give us a minus 6z. Okay. All right, so those guys are out. And then we're left over with the minus 1. Okay. So that'll just be minus 1. Okay. So we should have a z cube minus 6z squared minus 6z minus 1. So this will be our answer circled here on the right side.